Okay, so today we are going to solve the problem range some query immutable, and after solving this one we will also try to solve range some query 2D, which is a harder version of this one. But first let's understand what this question is saying. Okay, so we will given an array and there will be multiple queries or where we will be basically given the left indices and right indices, and we will have to calculate the sum between those left and right indices. Let's take an example. Suppose we have been given an array like this. Let's say okay, so from minus 2 4 5 0 minus 9 11 6 something like this. Suppose we have been given this array, and let's say also we are also given the indices of this array 3, 4, 5, 6, 7. So this is our array, okay, and we will given some L and R, that is the left indices and right indices. Let's suppose L is 2 and R is 5. So what we basically need to find is the sum of all the element between indices 2 and 5. That is 5 plus 0 minus 9, which will be minus 4, plus 11, which will be 7. So what we need to return is 7. So one obvious way will be to just basically brute force whatever is the range given. We will loop from that range L to R, and we will get the answer from there. But what will be the time complexity for that approach? That will be big O of n for all query we will be taking at worst and time. So that will be n into q. But we want to do better than this. So what we can do? So for that, we will use something known as prefix sum. That will pre-compute the sum of all the elements till the index number 1, 2, like that. Let me show you what is prefix sum. Then you will get the idea. Let me go to a new one. This is our array minus 2, 3, 4, 6, 5. Plus 2 is for array. So what prefix sum will contain is minus 2, then the sum of these two, that will be 1, then sum till here. So for that we can basically add 1 and 4, that will give us the sum till the here, because we have already calculated the sum till here in this index. And after that we can do similarly for this one. Also we can do 5 minus 6, that will give us minus 1. And for finding the sum till this index, we will basically add minus 1 to the 5, that will give us 4. And for finding till the last index sum, we can do 4 plus 7, that will give us 11. So this is basically the prefix sum array. By using this array we can answer all the queries in big O of 1. How? Let's see. Suppose we are told to find the, let's also write the indices 0, 1, 2, 3, 4, 5. Okay, so suppose we have been given this 1 as L and 4 as R. So we need to find the sum between 1 to 4, that is 3 plus 4 plus minus 6 plus 5, and that will be around 7 minus 6, 1 plus 5. Answer should be 6. So how we can find that is, to answer a query we can simply do, means the sum L comma R will be prefix sum of r minus prefix sum of l minus 1. How? Let's see. We needed to find a sum till 1 to 4. We already computed the sum till here in this index, and if you subtract the sum of this one from the whole index, we will basically get the sum till 1 to 4. So what I am saying, we already have the sum till 0 to 4 index, and from that, if we subtract the sum of 0 to 1 index, we will get the sum of 1 to 4 index. That is what we are required to find. So for that, we can simply do prefix sum of r minus prefix sum of l minus 1, which will give us a answer to all our queries in big O of 1 2. So the whole time complexity will boil down to big O of 1 and for building the prefix sum and plus q for each query, which is far much better than n into q. So let's see the code for this one, and then I think you will understand it better. So I have written the code over here. So in this one, I am building the prefix array. If the if there is, it is first index, the sum till here will always only be the first index only. So if I is 0, then I am basically storing the number whatever that is present. And after that, how we can build a prefix sum is basically by adding prefix of I minus 1 to the nums of I. This will give us 1. Similarly, for finding sum till here, what we were doing, we are basically adding 1 to 4. This is index. Let me know so that you don't get confused. And for finding the sum till here, what we are basically doing, we are already computed till I minus 1. So we will just add 5 with minus 6, and we will get the answer to the sum till here. And for finding the sum till here, what we can do, add minus 1 to 5, and we will get the sum till here. So that's why I am doing prefix of I minus 1 plus nums of I. And after that, if we are told to find the sum from for this range, so there's no l minus 1 here. So for that, we can basically return the prefix of r. Means what I am saying is, if l is 0, then l minus 1 will be minus 1, and that is not possible. Means in this of an array start from 0 only. So for that, we can basically just return prefix of r, because that what the prefix sum contain the sum till r index. So that's what I have written here. If left is 0, not equal to 0, then return prefix of right minus prefix of left minus 1. And if it is 0, it will return prefix of right. So let's see whether this code is running or not. As you can see, it is accepted. So that's all for this video. See you in the next one.